For many months, countless theories, rumors, and dramatic speculations have circulated around the mysterious interstellar visitor known as 3I/Atlas. Some people on the internet have gone as far as claiming that this object might be an alien spacecraft, a silent metallic traveler drifting through the Milky Way from some unknown civilization. These wild ideas gain strength because humanity has only recently begun detecting objects from outside our solar system, and every new discovery feels like it could hold some world-changing secret. Yet the more astronomers observe 3I/Atlas, the clearer it becomes that this object is not artificial, not mechanical, and definitely not a spaceship. It is a natural comet, behaving exactly as a comet should, revealing all the classic signs of icy material sublimating under the heat of the sun. The scientific evidence is not vague or uncertain. It is detailed, consistent, and extremely strong, leaving no realistic room for the alien ship interpretation. Observations from Gemini South, part of the NOIR Lab Educational Observing Program, have shown 3I/Atlas developing a clear coma and a beautifully distinct tail. These two features are like fingerprints of a true comet, impossible to fake and impossible to confuse with a technological object. A coma is a glowing atmosphere of gas and dust that forms around a comet's nucleus when the sun heats up its icy surface. The tail, meanwhile, stretches away from the sun as solar radiation pushes dust particles outward into space. These features are not optical illusions, not camera glitches, and not atmospheric distortions. They are physical structures created by real material. Volatiles like water ice, carbon dioxide, ammonia, and other frozen compounds, escaping into space as the comet warms up. This sublimation process is completely natural and extremely well understood. Comets are made of frozen ices that have remained unchanged for billions of years. When such an object approaches the sun, the rising temperature causes the ices to jump directly from solid form into gas. This gas escapes from the comet's surface and carries dust with it, creating the bright glow of the coma. The sunlight then pushes this gas and dust outward, forming the long tail that is so iconic in comet imagery. The same process has been observed for centuries in thousands of comets, from large famous ones like Halley's Comet to small periodic visitors that pass by the inner solar system every few decades. 3I/Atlas behaves exactly like all of them, which is a major reason why astronomers confidently identify it as a natural comet rather than something artificial. When we compare comets to asteroids, the differences become even clearer. Asteroids are rocky bodies that contain little to no ice. Because they are made mostly of stone and metal, they cannot form comas or tails. They can heat up, reflect sunlight, and even spin irregularly, but they do not produce vapor or glowing gas clouds. The instant scientists observed a tail behind 3I/Atlas, the asteroid and spaceship theories became scientifically impossible. No metallic spacecraft would naturally develop a tail of vaporized water molecules and dust. No engineered object would shed materials in a pattern identical to natural sublimation. If an alien civilization had built a craft capable of traveling between stars, one would expect it to emit structured energy signatures, radio transmissions, engineered heat patterns, or some form of propulsion exhaust. Nothing of that sort has been detected from 3I/Atlas. Instead, every observed feature matches the profile of an ice-rich celestial body undergoing perfectly normal thermal reactions. Spectroscopic analysis adds another layer of certainty. When the light reflected or emitted by 3I/Atlas is broken into its component wavelengths, astronomers can see the chemical fingerprint of the material it contains. These fingerprints reveal water vapor, carbon-based molecules, and volatile compounds known to be common in comets. These chemical signals are messy, unorganized, and entirely natural. They do not resemble the clean, engineered materials found in spacecraft construction, such as alloys, refined metals, or structured composites. Instead, they are the irregular mixture of ices and dust particles expected from an interstellar comet that formed in the cold outskirts of a distant star system billions of years ago. The chemical evidence is as strong as the visual evidence. reinforcing the conclusion that 3I/Atlas is a natural body. Another key point against the alien ship hypothesis is the object's motion. A spacecraft traveling through interstellar space would likely adjust its trajectory, slow down, speed up, or show signs of some propulsion system. Even if it were powered off, its motion would be different from that of a natural comet because engineered objects typically have smooth surfaces, symmetrical shapes, and predictable aerodynamics when interacting with solar radiation. 3I/Atlas, however, moves exactly the way a small icy body should. Its orbit curves according to gravity alone, and the tiny deviations in its path can be explained by jets of gas produced during sublimation, something scientists call outgassing. Outgassing is a well-known phenomenon in comets and has been measured many times before. It can nudge the comet slightly off its gravitational trajectory, but the effect is small and predictable. 3I/Atlas shows exactly this behavior, matching the physics of natural bodies rather than artificial ones. Although the alien hypothesis is not supported by evidence, its popularity is understandable. Humans are fascinated by mystery, and interstellar objects feel like messengers from the unknown. When the first interstellar object, Oumuamua, was discovered in 2017, it immediately captured global attention because of its strange shape and unexpected acceleration. Some scientists briefly considered the possibility of an artificial origin, and that discussion became a media sensation. When the second interstellar visitor, 2I/Borisov, appeared in 2019, it showed a clear comet tail, which settled the debate quickly. Now 3I/Atlas has arrived, and naturally the public imagines dramatic possibilities again. People want to believe in extraordinary explanations, even when simple, natural ones fit much better. Mystery is exciting, and the idea of an alien probe traveling between star systems is incredibly compelling. But extraordinary claims require extraordinary evidence, and in the case of 3I/Atlas, the evidence points only in one direction. What makes this object truly fascinating is not the false idea that it is a spacecraft, but the fact that it is one of the few interstellar visitors we have ever had the chance to observe. That alone makes it extremely rare and scientifically valuable. Each interstellar comet that enters our solar system brings with it material from a different part of the galaxy. These materials formed under the conditions surrounding another star, possibly in a system with planets, moons, and debris much like our own solar system billions of years ago. 3I/Atlas is a frozen time capsule, carrying ancient chemical information from a place humanity will probably never visit. Its long journey through interstellar space, passing near unknown stars and drifting through vast cosmic dust clouds, has shaped its surface and altered its composition in subtle ways. These clues can help scientists better understand how planetary systems form and evolve across the galaxy. Studying interstellar comets also helps astronomers learn how often objects are ejected from young planetary systems. Many comets in our own Oort cloud were likely formed closer to the Sun and then thrown into distant orbits by gravitational interactions with giant planets. The same thing happens in other star systems. When planets shift position or collide, or when stars interact in young clusters, icy bodies can be flung into interstellar space. Over billions of years, countless such objects drift between stars, and only a few ever pass close enough to Earth for us to detect. Every time one does, scientists gain a rare opportunity to sample the building blocks of a completely different star system. Even though 3I/Atlas is not a spaceship, its significance cannot be overstated. It reminds us that the galaxy is a dynamic place filled with wandering debris, ancient remnants, and long-traveled messengers. It also demonstrates the power of scientific observation to separate fact from speculation. While it is thrilling to imagine alien visitors, we must rely on evidence. And the evidence shows a natural comet, glowing with sublimating ice, drifting past the Sun after countless ages in the cold emptiness between stars. Its visit is brief, but its scientific value is enormous, and its journey is a story of cosmic motion rather than extraterrestrial engineering. In the end, 3I/Atlas stands not as a sign of alien technology, but as a breathtaking reminder of the natural wonders that exist beyond our solar system, waiting quietly for us to discover them.